Number 1. This is called a what? What's that blue line? What's this line? PB? Your perpendicular bisector, right? So if those parts are equal, those parts are equal, and those parts are equal. So we have 3x plus 1 equals 4x minus 7. If we move our 3x over, bring down your 1. 4 minus 3 gives me 1x. Bring down my minus 7. Now we can add our 7 over. I get 8 equals 1x, or if you say 8 equals x, or if you say x equals 8, either way. Did I answer the question? It says find AB. Here's AB. I take my 8, we plug it in. 3 times 8 plus 1. 24 plus 1 gives us 25. How do I know I did it right? Check on the other side. In my head, I'm like, 4 times 8 is 32. 32 minus 7 gives me 25 as well. I did it right. And I love, as I was walking around, I saw Landon working. He had it worked out. He had it plugged in, but when he checked the other side, it wasn't working out. And so he went back, he reworked the problem, he got the right answer, he plugged it back in, and he checked his work again. That's awesome. Corey? Number 2. Those parts are equal. We've got right angles, so that means my 5x plus 7 equals 7x. This one gave some of you a big fit, right? If I were you, I would move this 5x over to the other side. So that leaves me 7 equals 2x. We divide by 2. X equals 3.5. AB. 7 times 3.5 gives us what? 24.5, is that right? And then I take 3.5 and plug it in here. 5 times 3.5 plus 7 gives us 24.5. Did we do it right? Yeah. Number 3. In this diagram, perpendicular bisectors meet at point G. G is called my circumcenter. The circumcenter is the same distance to each of the vertices. So this distance and this distance and this distance are all the same. Find DC and find G, G, C. You know. C. EC. EC is right here. How big is EC? Matt, thank you for raising your hand. Matt, what is EC? 5. E is the midpoint, so if that's 5, that's also 5 because it's my perpendicular bisector. And then I look at GC. I want to know what GC is. GC is the same as this one, which is the same as this one. Do I know what any of those are? Yeah? What do you have, Mason? 7. This one's 7, that one's 7, this one's also 7. So GC equals 7. We got it? Okay. Quiz. We already quizzed on 5152 on Friday. We are going to do 5.3 notes. 5.3, angle bisectors. 2 I cans for today, 2 objectives. I can identify and use properties of angle bisectors, and secondly, I can identify and use properties of equidistant from endpoint. What's equidistant? Equal distance, the same distance, right? So here we go. I have distance from a point to a line. I know it's not necessarily a vocab word because it's a phrase, but this is something you need to know and have filled in on your paper. Distance from a point to a line is the length of the perpendicular segment from the point to the line. The length of the perpendicular segment from the point to the line. If I say, here's point S out here, and I say, find the distance from the point to the line, some people might measure it this way, some people might measure it this way, some people might measure it this way. So this is where we have this definition that comes in. We want the perpendicular distance from that point to the line, and same thing here. We want that perpendicular distance. So that just puts us all on the same page. We have the angle bisector theorem. Mine doesn't look like yours, but it's right here on your paper, so follow along, right, as I read it. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So next to your theorem, you have this picture here. It says if a point is on that angle bisector, I know it's bisected because those two parts are equal. I've got this point out here. If that's true, that point's on it, then this distance is the same thing as that distance. And the converse of the angle bisector theorem says this. If a point is in the interior, on the inside of an angle, and equidistant from the sides, then it lies on the bisector. If I have a point in here, and this distance is perpendicular, and this distance is the same, and it's also perpendicular, if that's true, then I know this angle is the same as that one, and that point lies on the bisector. Your two theorems. You want to keep this handy as we go through this. Find measure of angle GFJ. Trace it with your pencil. G to F to J. I want to know how big is that angle. Taylor? 42 degrees. Yeah. If those are the same segment length and they're perpendicular, if that's 42 degrees, that's also 42. Clean it up. Tell me measure of angle GFJ equals 42 degrees. A soccer goalie's position relative to the ball and goalposts form two congruent angles as shown. So this angle is the same as that angle. Will the goalie have to move farther to block a shot toward the right goalpost or the left goalpost? Both. Why both? If both of those angles are in the middle, he's standing right in the middle, right? You want to be in the middle so that the distance to the left and the distance to the right are the exact same. For what value of x does P lie on the bisector of angle A? So if I have this angle bisector in here, my angles are equal, they're perpendicular, then I need to know what value of x is going to make them equal. How do we solve? Set them equal. Solve it. So x equals 4. I answered the question, but how do I know I'm right? Plug it in. 4 plus 3 is 7, and 2 times 4 is 8 minus 1 gives me 7. So we're good. 1, 2, and 3 on your own. Number 4 we'll talk about together. Number 1, my angles are equal, they're perpendicular, so x is equal to 15, right? Those parts are equal. Number 2, these segments are congruent, they're also perpendicular, so that means my angles are going to be equal. 3x plus 5 equals 4x minus 6. When we solve it, what'd you get x equals? I got 11 too. 5 and 6 gives us 11 equals x. Or x equals 11. Plug it back in and check it. You should get the same angle measurement for both of those. Number 3. My angles are equal. They're perpendicular, so what are my segments going to equal? What's x? If I subtract my x over, I have negative 1x equals negative 5. Divide by negative 1. X equals a positive 5. Plug it in. 5 times 5 is 25. 6 times 5, 30 minus 5 is also 25. Number 4. Do you have enough information to conclude QS bisects that angle? Does that look like one of the theorems? Look at your front page. Does it look like 5.5 or 5.6? Why not? What's missing? It doesn't have the box. What's the box mean? What's the box? It doesn't have a 90-degree angles. It doesn't tell us that the lines are perpendicular. So do we have enough information? We say no. We don't know the segments are perpendicular. Remember the symbol for perpendicular? When you get your worksheet, Try 1 through 8. Practice, it'll take you all of about 5 minutes, and then we'll go over it. No, and then we'll finish the notes, so don't put your notes away. The last 4 on here require you to match them up to your theorems. So say yes because of theorem whatever, or say no because it's missing whatever it's missing. One through 8, front side, on your own. Alright, here we go. Number 1. If our angles are congruent, they're perpendicular segments, and if this is 7, that is also AD equals 7. Let's be careful. Let's not put it in degrees, because it's the length of the segment. So you can just say AD equals 7, and it'll be perfect. Number 2, we are talking about angles, though. It shows these segments are congruent, they're perpendicular, so if this is 20 degrees, the other one is also going to be 20 degrees. Measure of angle DBA is 20 degrees. Number 3, when we set them equal, we solve for x. X is 5. If you plug it back in, they're the same. It's just a quick way to check your work. So we get x equals 5 here. Number 4, over here. We set them equal, we solve for x. X is 4. You plug it back in, it checks out. Number 5 is DA equal to DC. Yes, because DB is the bisector of ABC. Sure, we know these two parts are equal to each other. We know they're perpendicular. Because that's the bisector, we say, yeah, they're equal. What theorem is that? What theorem does that look like? What theorem number is that? 5.5? I agree. So tell me yes, and tell me theorem 5.5. Number 6, do we have enough information here? No, because they are different lengths. What's missing? What's missing in here? Yeah, they're different lengths, but why are they different lengths? Because there's no box. There is no right angle symbol. They're not perpendicular. Number 7, can we conclude BD is the bisector? Why? Because of 5.6. So you can say yes by 5.6. Those parts are congruent. They're perpendicular. We're good to go. And 8, those two parts are congruent, but that's all we know. So is there enough information? No, we're missing the right angle. You don't have the right angles in there. Good. Okay, pull out your notes. Make sure you still have your notes out. Let's go back there. Here I have concurrency of angle bisectors of a triangle. What does the word concurrency mean? This is already on your note sheet. On the back, in the box, it says concurrency of angle bisectors. Intersection. Make sure you get it on your paper because of your quiet responses. I'm not sure that we know that. Concurrency means intersection. It's the intersection of the angle bisectors of a triangle. And under that theorem, it says this: the angle bisectors of a triangle intersect at a point equidistant from the sides. Now we're talking about equidistant from the sides, not from the vertices anymore. Did you see that? Did you underline that? Equidistant from the sides? So check this out. I have this angle. It's bisected so that this part and that part are equal. I have this angle. It's bisected so that this part and that part are equal. And my third angle is bisected so that this and this are equal. So this part and this angle bisector and this angle bisector, they all intersect at this point in the middle here, and that point is called our incenter. Okay? Perpendicular bisectors intersect at the circumcenter, angle bisectors intersect at the incenter. And the incenter is the same distance, what we just said is the same distance to the sides. So incenter is the point of concurrency of three angle bisectors. Incenter, point of concurrency, or your point of intersection of three angle bisectors. So this is kind of fun because here's what happens. The distance from the incenter to the sides is the same for all three of them. So if I were to take a compass, put the point at P, and measure the distance to the side, because this distance and this distance and this distance are all the same, if I were to measure that distance and make a circle, I would form a perfect circle just like this one down here, inside of that triangle. It's kind of fun. You guys are like, not really, Miss Room. So here, in the diagram, N is the incenter of triangle ABC. N, that's my incenter, so this distance and this distance and this distance are all the same. Do I have any of those distances marked? No. There's no number at this one, there's no number at this one, and there's no number at that one. So we're stuck?
Yeah.
Look at this. This is 20, this is 16, and this part in here, I don't know. But it's the same distance here, and it's the same distance here. This distance and that distance and that distance are all the same. If this is 90 degrees, isn't this also 90 degrees? On your paper, take this triangle, and we're going to pull it out, and we're going to redraw it. This is 20, this is 16, this is x. 20, 16, and x. Redraw it. We covered the basics of angle bisectors. I'm confident you guys have that. But this is the new part. This is the part where it's going to take a little bit more work. Have you ever heard, raise your hand, have you heard of the Pythagorean theorem? On the Big Bang Theory? Really? Write this down. Pythagorean theorem. What's the Pythagorean theorem say? A squared plus, there you go. Some of you have heard of it before. A squared plus B squared equals C squared. And C always stands for the hypotenuse. It's like the odd one that's on the end, because there's only ever one hypotenuse in the triangle. A and B are both legs. So this triangle that I have pulled out here, raise your hand and tell me what's the hypotenuse. Raise your hand and tell me what is the hypotenuse of this triangle. Heather? 20. How do you know it's 20? It is the longer side, but how do we find it real quick if they look close sometime? Across from the right angle, right? If you find the right angle and draw an arrow across from it, this is our hypotenuse. Right? So label it. That's your hypotenuse, or we can call it our C value. Those both mean the same thing. Both of these are legs, so if I call this one A and this one B, or vice versa, it doesn't much matter. Make sure you get those labeled. Plug it in your formula. My A value is x, so I have x squared. My A value is x. I labeled my B value as 16 squared, and my C value then is 20 squared. Leg squared plus leg squared equals hypotenuse squared. Do the math. 16 squared is 256. Good, Justin. 20 squared is 400. 20 times 20 is 400. Just like any other equation, we got to get x by itself. Subtract your 256 over. X squared equals 144. What's the opposite of add? Subtract. What's the opposite of multiply? divide. Instead of squaring a number, we need to, what's the opposite of square? Find the, who said it? Say it. Yeah, good, Taylor. Find the square root. Find the square root. So those cancel. So I'm now just left with x. Square root of 144 is 12. You guys know those because we've been working with those. Look at that. X is 12. So I'm going to come in here, I'm going to go crazy. I'm like, that side's 12, right? And just watch 1 second so you don't miss this. I solve for x is 12, so I put on my picture. This picture came from right here, so this side's 12. And this distance is the same as this one, so this one's 12, and this one's also 12. Do you see that? Okay. So the question says find ND. Where's ND? Right here, right? What is ND? 12. Clean it up. ND equals 12. Circle your answer so I know what you got. Let's go to your homework sheet. Back here. The back side. Number 9. Point T is the incenter of triangle PQR. Find ST. ST is the same as what? TW? Which is the same thing as? TW, WT, right? All three of those are the same. Do I know how big any of those are? Out of them? This one's 15, so this one's also 15, and so that one's also 15. ST equals 15. That one was easy. Number 10. Find the value of x that makes P the incenter. So if P is my incenter, I know that this distance and this distance and this distance are all the same. Draw it in with your pencil so you see what distances have to be the same. Do you have any numbers for any of those three? No. So look at what we have. Here's a 12. Here's a 13. Here's a right angle. But x is over here. It's okay. If that x is here, I can call this one x, and I can also call that one x. All three of those are the same. Take your triangle and pull it out and redraw it. We have 12, right angle, here's x, and this is 13. Pythagorean theorem only works with right triangles, which fortunately, almost everything we do in here is with right triangles. But just so you know, this only works with right triangles. Pythagorean theorem says a squared plus b squared equals c squared. And c is the hypotenuse. Raise your hand and tell me, what's the hypotenuse here? Corey? 13. Here's my right angle. Across from that right angle is my hypotenuse, so that's my c value. If you want to label it hypotenuse, that's fine, but I'm going to call that c. He's the odd one. That's the hypotenuse. These two are both legs. They go together. So I'm going to call this like my A. I'm going to call this one like my B. I have my A, my B, and my C. Plug them in the formula. My A value is x squared. My B value is 12 squared. So do the math. 12 squared, you guys know these by now, 144. 13 squared is 169. Subtract your 144 over. Instead of squaring it, we do the opposite, which is square root. Not square root, square root. X equals 5. Take it, put it on your picture. X is 5. So this side is 5. So I come in my picture, I'm like, this side matches up here, so this is 5. This is 5. This is 5, right? All those three are 5s. So what's the question say? Find the value of x. What does x equal? 5. 11. You Your neighbor's moving a new bird bath to his triangular backyard. I don't have a picture, so I'm going to draw one. I don't know what it looks like, but he's got a triangular backyard. He wants the bird bath to be the same distance from each edge of the yard. Where should your neighbor place the bird bath? Same distance to each edge of the yard, each side. What's that? At the circumcenter. What's the new one today? The incenter. The incenter. If I put that bird bath at the incenter, it's going to be the same distance to each of the sides. Where does he put it? At the incenter. Why? So, the bird bath. So the bird bath is the same distance to each side. What's the incenter deal with? How do we find the incenter? By drawing in the... What did we talk about today? Perpendicular is circumcenter. Perpendicular bisectors are circumcenter. Angle bisectors are incenter. Right? If this is my incenter, I draw my angle bisector, my angle bisector, my angle bisector, and that place they intersect, that's called our incenter. And 12. You're planting a tree at the incenter of your triangular front yard. Here's the incenter. Use the diagram to determine how far the tree is from the house. I want to know this distance right here, which is the same as that distance, and that distance. Do I know any of them? This is 20, this is 16. I don't know this side, which is the same as that one, and that one. I don't know any of those three, right?
Go A, B, C.
Take a triangle, pull it out, and redraw it. So there's a right angle, this is 16, this is 20, and this I don't know. What's my hypotenuse? 20. Across from the right angle, that's my hypotenuse, that's my C value. And then we have A and B, whichever way you want to label them. 16 squared, so A squared plus B squared equals C squared. We actually already did this one, didn't we? In the notes. 256 plus X squared equals 400. Solve it. The opposite of squaring it is taking the square root. So X equals 12. Put it back in your picture. This was 12. So this was the same part that was 12. And this distance are the same. And this distance is also the same. So what's this tell us about the question? Who cares? What's that 12 tell us? That is what X equals. It's how far the tree is from the house. Hang on to your calculator. So I say the tree is 12 feet from the house. Right? Hang on to that. I'm going to come around and check it in 1 second here. You can put your calculators away, but then go back to your seats.